All right, this is day 10 notes, states of matter, and we're going to start off with the kinetic theory of solids. In the solid state, particles will have the lowest or least amount of kinetic energy. Remember, kinetic energy is the energy of movement, so we're looking at how much atoms and molecules are moving. The intermolecular forces in a solid state are going to be higher than intermolecular forces in a liquid or a gas. The particles in a solid state are going to be in a fixed or unchanging position. The particles will only vibrate in place. Solids will not flow. There are two different types of solids: crystalline, which are solids that contain particles that are arranged in an orderly, repeating pattern. An example of this would be table salt, or NaCl, sodium chloride. You'll notice when you look at salt granules, it's going to be small little crystals of salt. The other type of solid is called an amorphous, which means that it lacks order in the particles that make it up. An example of an amorphous solid would be glass. The chemical formula for glass is silicon dioxide. Let's take a look at what these substances look side by side. This is silicon dioxide, and this is salt, like table salt. If we're looking at the arrangement of the molecules or atoms, there's no set pattern. They're joined to each other, but some of these rings are small and some of the rings are larger. Some of them contain 5 and some of them contain more than 5. Oxygen. When we're looking at the crystalline solid, we can see that it's a very regular pattern. We always have sodium ion, chloride ion, sodium ion, chloride ion, sodium ion, chloride ion, in a regular repeating pattern. There are different types of crystalline and amorphous solids. So the first one is ionic. You're going to have a metal and a non-metal elements that are joined together. The attraction of the positive and negatives will increase the likelihood that it's going to stay in the solid state. Remember when we did experiments in the beginning of the year, it took a lot more energy to get to the melting point of salt than it did for something like sugar. Ionic substances are always crystalline solids. They're always going to have that repeated pattern. The strong intermolecular forces, again, are going to make it difficult to break it apart. You're going to need a lot of energy to cause this to go from a solid to a liquid state. Molecular. Molecular substances are substances that have covalent bonds, and that's going to be elements that are nonmetals joined together. These are held together by strong covalent bonds, but they're going to have weaker intermolecular forces. The intermolecular forces for ionic solids are much stronger than in molecular solids. If you remember our experiment, it took a lot less energy to cause the sugar to go from solid to liquid state than it did for the salt molecules. Now, molecular can be either amorphous or crystalline when we're looking at their structure. So some will be very regular in a repeated pattern. Other molecular substances are going to be very random in their pattern. Phase changes for solids. A solid will melt when the particles in the solid state have enough kinetic energy to break free from their fixed positions. The temperature at which this occurs is going to be called the melting point, which we're going to abbreviate in the notes as MP. Since intermolecular forces are stronger in ionic solids, they'll have higher melting points than molecular solids. Sublimation. Sublimation is the conversion of a solid straight into the gas phase without going through a liquid state. The reverse process is called deposition. So when a gas goes straight from a solid phase to from the gas phase to the solid phase, that we call that deposition. When a solid goes straight from solid to gas, it's called sublimation. Sublimation is going to occur when the vapor pressure of the solid is greater than or equal to the surrounding atmospheric pressure. So whenever vapor pressure is greater than atmospheric pressure, you're going to have sublimation. The substances are going to go straight from a solid to a gas without going through the liquid phase. The vapor pressure of solids is usually much lower than that of the vapor pressure of liquids. Because remember, in a solid, those molecules are not moving very much. They're in fixed positions. They're only vibrating a little bit. So for one of those molecules to have enough kinetic energy to break free, it's going to be a much less chance that any of those molecules have enough energy to do that. Vapor pressure will increase if we heat the solid, though. Most substances will melt before the vapor pressure will equal the atmospheric pressure, which is why we don't see sublimation very often. It's easier to get a solid to sublime by lowering the atmospheric pressure. Dry ice will sublime at room temperature and pressure because it has a high vapor pressure due to very weak intermolecular forces. And dry ice is basically solid carbon dioxide. We're going to watch a video in class that talks about the motion of solids. And that's the end of the notes for today. We're going to continue on